In the previous video lecture, we have seen about the timing diagram, the important concepts in that, like instruction cycle, machine cycle, T states, and the timing diagram of 5 machine cycles. Fine. So in this class, we are going to draw the timing diagram of each and every instructions. For sample, we are going to take only 3 instructions. Okay. So I will give you that 3 instructions now. Try to write the machine cycle that it requires. Fine. So pause the video for a minute or two and try to write the machine cycles that these instructions require. Okay. So the instructions are MVIB, 43. So second instruction STA 526A. Third instruction NCO. Okay. So these are all hex values. Fine. Pause the video for a minute or two. Try to write the machine cycle for these instructions. Fine. Okay, I think you guys have written the machine cycle that these instructions required. So we will see one by one now. The first instruction that I have given you is MVIB, 43. Okay. So what this instruction means, MVIB, 43, is nothing but you have to, this is move immediate. You have to move the immediate value 43 to this instruction B. Okay. So consider the memory address of this instruction is 2000. Okay. So how this instruction will be stored in the memory? At 2000, opcode of this instruction will be stored. So opcode for this one is 06, which is nothing but the opcode of MVIB. Okay. So at 2001, what will be stored? The immediate value 43. Okay. So now tell me what the machine cycle does it require? Okay. It totally requires 2 machine cycle. What are they? So this is the opcode. To read the opcode, you have to perform opcode fetch machine cycle, right? So and the next thing, by seeing to this opcode, it knows that you have to transfer some value to the B register. That's all it knows. It should know the value 43, right? So which is stored in the memory 2001. Okay, now we have to read this 43 from the memory location 2001. Then what machine cycle you required? Yes, that is memory read. So as a whole, MVIB, 43 requires 2 machine cycles. So they are opcode fetch, memory read. Okay, we will now we will see the timing diagram. So as a side by side, you have to draw first opcode fetch, and second you have to draw the memory read, as we have discussed in the previous video lecture. Fine. So this is the timing diagram of MVIB, 43. Okay, it requires 2 machine cycles. So and this opcode fetch requires how many T states? 4 T states, and memory read cycle requires 3 T states. As a whole, 7 T states this particular instruction requires. Okay, that is what written here. Fine. So the first machine cycle is opcode fetch and second is memory read. So as you all know that, so I will keep here. So as you all know that the signals that we require: clock, higher order address, lower order address, address latch, enable, control lines, and read signal, right? So since we are performing opcode read, so the control signals value should be 0, 1, 1. Okay, that you should not change it. Fine. It should be retained till opcode fetch. Okay. So the next is you have to read the opcode which resides in the address 2000. So now we have to know this value. So this lower byte value 00 will be put in the lower byte address, and higher byte 20 will be put in the higher order address. Fine. During at this time, at T state 1, ALE should be high in order to represent the value in the lower order address lines are address values and not data values. So this we have discussed in opcode fetch machine cycle itself. Just recollect it. So at T state 2, what will happen? It reads the opcode which resides in this memory location. Fine. So at this time your read bar should be low in order to read this value from this memory location. Once it read at t state 3 and 4, what will happen? This opcode will return into the instruction register. Fine. So now the opcode fetch is over now. So next we will see about memory read. Okay. So why you are performing memory read? Because this 43 is stored in the memory location 2001. We have to read it and we have to transfer it to B register. So this memory read requires three T states. Fine. So at the first is T state, we should know the address of this immediate value. So for that, the address value is 2001. So 01 is lower byte, so it's stored in lower order address. So 20 is higher byte, higher order address. And the most important thing is, so now this control lines should be changed because we are performing memory read. It should be changed like IO/M bar as 0. So memory operation S1 S0 will be like 1 0. Okay, this value has to be changed. So that's why the signal changes here, and you have to write the signal values in the bus itself. Fine. So at T state 2, what will happen? The read signal should be low in order to read the value 43 in this memory location, and it will put in the data bus. So after that at T state 3, the value in the data bus will be written into the B register. Fine. Okay. So this is how the move immediate instruction works and the timing diagram of move immediate instruction. Fine. So the next instruction that I have given is STA5268. So for example, the address of this instruction is 41FF. For example, I am saying 5268. So at 41FF, what will be stored? The opcode of STA will be stored. So that is nothing but 32. So the next address would be 4200, where this address location has to be stored, which is nothing but 68 lower byte, then the higher byte 52. Okay. So what this will do, this instruction, it stores the value in the accumulator into the memory location 5268. So what the machine cycles does it require? So obviously the first thing is opcode fetch, right? So the second thing is this memory, we should know this memory location. So this is stored in the memory address itself. So to read the lower byte and higher byte, we have to perform memory read. So this also requires memory read because individual lower byte and higher byte are stored separately. So to read this a memory read, to read this you require another memory read. Okay. So now you know the operation, you know the memory address. What the next thing you have to perform? The value in the accumulator should be written into this memory location 5268. So this operation is memory write because you are going to write the value into a memory location. So as a whole, this instruction requires 4 machine cycles. Fine. So how many T states does it requires? So the opcode fetch requires 4 T state, memory read 3, then a memory read 3, then a memory write 3. So as a whole, it requires 30 T states. Fine. Okay, so this STA5268 requires 13 T states and 4 machine cycles. So those 4 machine cycles are opcode fetch, 2 memory read and 1 memory write instruction. Sorry, one memory write machine cycle. Fine. So now we will see the timing diagram of that. Okay, so this is the timing diagram of STA5268. Okay, so the first machine cycle is opcode fetch. I have already told that this opcode is stored in 32 is stored in 51FF. So at T state 1, I should know the address of this opcode and it is stored in the address bus. So higher order 41, lower order FF, address slash should be high because the value stored in this lines are address. So to enable it, address slash enable is high. So at and then the control signals, so opcode fetch, so 0 1 1. So this is IO slash M bar, this is S1 and this is S2. So at T state 2 it reads the opcode, at T state 3 and 4 it stores this opcode in the instruction register. Okay, so the opcode fetch is over. So next memory read to read this lower byte address value. So its address is 4200, so that value is stored. Since we are performing memory read, the control signal should be varied, that is 001. Fine. So address latch enable should be high to know this. The value is an address, and then at T state 6 it reads the value in this memory location 4200, that is nothing but 6A. Fine. So next the memory read, next also memory read, the control signals retain the same. The memory address is 4201, so in that we have stored 552. That value will be put in the address bus. Fine. So at the next cycle is memory read. So what's the memory read? We have to write the value. For example, if accumulator has the value 72, this 72 has to be stored in this memory location 526A. So the next operation is memory write. So the control signal should be varied, that is 0 1 0. So I'm sorry, it is 0. So IO slash M bar is 0. So memory read S1 S0 value. So for memory read it should be 0 1 0. This is also 0 1 0. So for memory write it is 0 0 1. Fine. It has to be changed like 0 0 1. So it's wrongly mentioned here, sorry. So this control signals should be varied. Okay. So now this is an address value that we have read in the previous machine cycle. So in this 52 is a higher byte and 6A is a lower byte. So that is put in the corresponding address lines. Fine. And to this address line, this 72, example I have taken 72, should be written. So at that time write signal is used. So till then write is not performed. So it should be high since it's an active flow pin. So at T state 3 it should be low in order to write that 72 into this memory location. So in this example they have taken C7. Okay, fine. So we have said about 72. So this 72 will be written into the bus. So later at the last T state T13, this value will be written into this memory location 5 to 6A. Okay. So now you got how this store works. So try to write for LDA 6352. Okay. Try to write for it. Okay. The next instruction is in COH. Okay, not CO, it's actually C0. Okay, so in C0H, so what this instruction represents, the processor has to get a value from the peripheral device connected with this port address C0. Okay, this C0 is nothing but port address. This we have discussed in the instruction set itself. Okay, the processor will be connected with any of the peripheral devices. Okay, input device I am writing on this, so which is connected with the port whose address is C0. So now the processor has to receive some value from this input device. Fine. So how this operation works, it receives the value from C0 and stores this in accumulator. Okay, so if its address is 4125, for example, the address of this instruction is 4125, for example, how it will be stored? So first the opcode will be stored. So in CO opcode is DB. Fine. So which is nothing but opcode. So for this operation required is opcode fetch. So at the address 4126, this port address will be stored because you are going to perform in operation from the port address C0. Okay. So you have to know this address. So this is stored in the memory location. So the next machine cycle is memory read. Okay. This in CO instruction requires 2 machine cycles, and this requires 4 T states and this requires 3 T states, as a whole 7 T states. So after it knows the C0 address, what it has to receive the value from this location. Okay, so that operation is input read, IO read. Okay, IO read machine cycle. So this requires as a whole 10 T states this instruction requires. Okay, the machine cycle this in instruction requires are opcode fetch, memory read and input output read. Fine. Okay, this is the timing diagram of in CO instruction. Okay, so as I have told you, the address of this instruction is 4125. To read the opcode, this address is required, so that is put in the corresponding address, and the control signals are in the value 0, 1, 1. Fine. So it knows the address, then it reads the opcode and stores in the instruction register. So that will happen in opcode fetch. Then in memory read, the control signal should be varied as 0, 1, 0. Okay, so because we are reading the port address, so that location is 4126. Fine. So at T state 6, it reads the opcode, it reads the address C0. So the next thing is, now we know the operation and the port address, you have to perform this operation now. That operation has nothing but in and out read. So it has to read from the memory location C0. So that C0 is written in both higher order and the lower order address. Okay, so now the processor goes to this location, finds the value whatever in this. So for example, they have given 5E at this location, 5E value is there. So it reads that 5E value at T state 9 and return this value in the accumulator at T state 10. Fine. So for this, the control signals are this is read operation, no? So 1 IO read, don't forget that. So 1, 1, 0. So this is what the control signals value. So here 0, 1, 0 because we are performing memory operation. Here 1, 1, 0 because we are performing in and out operation. Fine. So the read signal to be low to read the value from this address location. Fine. So now we all know how to draw the timing diagram, right? So for sample, we have taken only 3 instructions. Try to draw for the other instructions that you know. Okay. So previously we have discussed about the instruction sets, no? So for each and every instruction, try to draw the timing diagram for that.